Hello everyone, I am Dr. M. N. Sarvana Kumar from the Department of Electronics and Instrumentation Engineering from Aero Secondary Engineering College. Now we are going to look into a topic in the power electronics, which is the basic introduction of the rectifier. Before entering into the topic, the objective of this is to provide a practical knowledge on the rectifier, on the operation of the rectifier circuit, and the outcome will be at the end the students can able to understand the behavioral operation of the rectifier circuit. Now on getting into the topic, we have to know what is rectifier. A rectifier is an electrical device that converts the alternating current to direct current. This process is called rectification. The rectifier will be supplied with the alternating current. At the output, you will be getting a pulsating DC. For example, if you are considering a mobile charger, the alternating current is converted to direct current and it is supplied to the mobile for charging. On behalf of this, we have to know what is inside the mobile charger. There will be a pulse step down transformer connected to a bridge rectifier. Then it will be connected to a capacitive filter to remove the AC ripples. On coming to the rectification process, the AC line voltage is given as an input to the transformer. At the output of the transformer, you will be getting a step down voltage which is given as an input to the diode bridge rectifier. The output of the diode bridge rectifier, you will be getting a pulsating DC voltage. To there you will be getting a AC ripples. It is minimized by connecting to the filter circuit. At the output of the filter circuit, you will be getting a uncontrolled DC voltage. What does uncontrolled DC voltage means? Whenever there is a changes in the input, accordingly the output will get changes. To avoid this one, the output of the filter will be given to the voltage regulator to make the voltage to be constant, and it is applied to the load. The load may be mobile phones, laptops, batteries, etc. This rectification process contains three stages. Coming to the first stage, the AC 230 volt 60 Hz will be stepped down to 9 volt 60 Hz, and coming to the second stage, the stepped down voltage of the transformer will be given as an input to the diode bridge rectifier with filter. At the output, you will be getting an uncontrolled DC voltage. At the stage 3, the uncontrolled voltage will be controlled through a voltage regulator and it is given as an input to the load. Next, coming to the types of rectifier. Basically, there are two types of rectifiers. First one is half wave rectifier. Second one is full wave rectifier. The first type of rectifier circuit is half wave rectifier. The half wave rectifier circuit is supplied with an alternating current. Here, only the positive half cycle alone conducts, the negative half cycle won't conduct. At the output, you will be getting the half conduction. So, the name half wave rectifier. The output DC voltage can be calculated by the following two equations. First one is the RMS output voltage can be calculated by the half of the maximum peak value. Then the average output voltage can be calculated by the maximum peak value divided by pi. The second type of the rectifier circuit is full wave rectifier. Here, the full wave rectifier circuit has been supplied with the alternating current. Here, both the cycles are in conduction. That means positive half cycle as well as the negative half cycle will conduct. At the output of the rectifier, you will be getting the full conduction. So the name full wave rectifier. The average output voltage can be calculated by the following ideal two equations. The average output voltage can be calculated by twice of the maximum peak value divided by pi, and the RMS output voltage can be calculated by the maximum peak value divided by root 2. Next, on coming to the operation of the rectifier, first we will look into the operation of half-wave rectifier. Then we will go for the operation of full-wave rectifier for both center tapped configuration as well as bridge configuration. On coming to the operation of half-wave rectifier, the AC supply was given to the primary of the step-down transformer, and the secondary was represented as node A and B. There, the half-wave rectifier circuit was connected using R load. So, for the positive off cycle, the diode will be in forward bias. So, the current conduction will be from the node A through the diode, through the load resistor, and ends at the node B. So here the diode will be in forward bias and it will be in conduction. So for the negative off cycle, the diode will be in reverse bias, so there won't be any conduction. On looking into the output graph, for the positive off cycle, you will be getting the input waveform, and coming to the negative off cycle, there won't be any conduction. So only half conduction has been occurred there. So the name half-wave rectifier. On seeing the disadvantages of half-wave rectifier, the output contains AC components whose frequency is equal to the supply frequency. So if proper filtering is needed, since there was an off conduction at the output, so the power delivered to the load is very less. Next, on seeing the output frequency, when the input AC completes one cycle, the rectified wave will also complete one cycle. So the output frequency is equal to the input frequency. Next, we are going to see the operation of full-wave rectifier using center tapped configuration. Here the circuit contains two diodes D1 and D2 and a center tapped transformer. During the positive off cycle, the diode D1 will be in forward bias, so the current flow will be from the point A, D1, through the load resistor and ends at the point O. For the negative off cycle, the diode D2 will be in forward bias. Here the current flow will be from the point B, diode D2, through the load resistor RL and ends at the point O. On looking into the output graph, for both the off cycles, you will be getting a positive cycles. This is because for both the cycles, the current flow through the load resistor is in the same direction, that is also in the positive direction. So the output you will be getting a positive cycles. Since there is a full conduction in the output, so the name full wave rectifier. Coming to the operation of full wave rectifier using bridge configuration. Here in this configuration, the need of center tap transformer is eliminated, and in this circuit we will be using 4 diodes instead of 2. And for the positive off cycle, from the time period D0 to T by 2, the P will be positive and Q will be negative, and D1 and D4 will be in off state, and D2 and D3 will be in on state, and the current flow will be from P, D2 through the load resistor R, D3 and ends at Q. For the negative off cycle, that is during the time period t by 2 to t, P will be negative, Q will be positive, and D1 and D4 will be in on state, and D2 and D3 will be in off state, and the current flow will be from Q, D4 through the load resistor R, D1 and ends at P. On looking into the output waveform, for both the positive off cycle and the negative off cycle, you will be getting positive output. This is because the current flow through the load resistor is same for both positive and negative off cycle. So at the end you will be getting full conduction. So the name full wave rectifier. On looking into the output frequency of the full wave rectifier, when the input AC component completes one cycle, the rectified wave also completes two cycles. So the output frequency is equal to the twice of the input frequency. On coming to the advantages of the full wave bridge configured rectifiers are: the need of center tapped transformer is eliminated, and the peak inverse voltage is one of the top of the center tapped circuit, and the output is twice than that of the center tapped circuit. And coming to the disadvantages, it requires 4 diodes, and the internal resistance voltage drop is twice than that of the center tapped circuit. Next is voltage regulator. Before entering into this, we have to know what is the need for using voltage regulator. As we discussed before, the AC input has been given to the step down transformer, and the step down voltage is given to the input for the rectifier circuit. At the output of the rectifier circuit, you will be getting a DC components, that means pulsating DC. So it contains some AC ripples. So to avoid that, you will be using a filter. Filter is nothing but a circuit used to reduce the fluctuation in the rectified output voltage or ripples. This will provide a steadier DC voltage. So the output of the rectifier is containing some AC ripples. It is reduced by the filters. So at the output of the filter, the output is uncontrolled DC. So to make that voltage to be controlled, that is constant, you will be going for a regulators. So regulator is nothing but a circuit used to produce a constant DC output voltage by reducing the ripples to negligible amount. The output of the regulator is given to the load. Basically, we will be using two types of voltage regulating ICs, that is 78 series regulating IC and 79 series regulating IC. The 78 series voltage regulating ICs are positive voltage regulating ICs, and the 79 series voltage regulating ICs are negative voltage regulating ICs. So on coming to the pin configuration, which is shown in the figure, the first pin represents the input, the second pin represents the ground, and the third pin represents the output. The output obtained from the filter, which is a uncontrolled DC output, which is given as an input to this IC in the first pin. At the output, that is from the third pin, you will be getting a constant output voltage. So since it is a positive voltage regulator, the available ICs in the market are 78052 to 7824. The first two digits represents the positive voltage regulator, that is 78. The last two digits 05 to 24 represents the output voltage. For example, if you are considering a 7805 IC in the sense, it is a positive voltage regulator which gives an output of plus 5 volt. This IC can able to operate at a minimum voltage of 7.3. The another one is 79 series voltage regulating ICs. As I said before, this is a negative voltage regulating ICs. So the availability in the market are 79052 to 7924. Since the first two digits represents the voltage regulating series, that is 79 represents the negative voltage, the last two digits represents the output voltage. For example, if you are considering a 7905 IC in the sense, the last two digits 05 represents the negative voltage. For this IC, the minimum input voltage will be minus 7.3 volt. And that's all about this session. For any queries, please comment below. Thank you.